Hey guys, welcome back to my channel. A while back, I released a video where I showed you guys how to run a YOLO model within React Native. Today, I'm going to continue this series. In this video, I'm going to show you guys how to run the LiteRT.js module within React. Just like our React Native video, I'm going to be running the same YOLO model within my React frontend. So let me show you the project that we're going to build in this video. So basically, we're going to have a simple React app that loads my YOLO model within the front end. And then I browse to an image. So for example, my coins image or an image of coins. I select it, I scroll down, and then I click on run inference. And then I get my detections. Or in other words, my model is going to perform inference on this image. All of this is being done on the front end. Now that you know what our project is going to look like, let's now head to VS Code and begin our project. Alright guys, so here I am in VS Code and I'm going to be running my project within a dev container. I'm going to be building a React project using Vite. So to create a Vite project, I go npm create Vite at latest and then I hit enter. So create Vite, yes, and then my project name. So I'm going to call it LiteRT.js tutorial, and then my framework. So it's React, and then I want TypeScript plus React compiler, and then I want to install with npm and start now. And now we wait. All right, so now my project seems to be running. So let me open a web browser. So here I go, localhost. And I believe it's 5173. Yes, 5173. Hit enter. However, notice that it's not running. So Vite needs a little setup when it comes to dev containers. So to do so, I go vite.config.ts, and just below plugins here, I'm going to go server, and then it's an object. So we're going to have a host. So the host is going to be 127.0.0.1. That's it. So let me close the server. Let's clear it and then run the server again. Whoops, not create Vite. It's actually npm run dev. So npm run dev. Okay, so I'm in the wrong folder. So cd LiteRT.js, clear it again, npm run dev. So let's go back to my browser. Let's refresh, and now my project is running. Let's now move on to actually setting up our project. So first, I'm going to have to install my dependencies. So within a new terminal, I'm going to navigate to my project. And then here, I'm going to go npm install LiteRT. Let me zoom in actually. LiteRT.js/core. Let me close the side panel. So it's LiteRT.js/core. Actually, it's better for me to bring up the documentation. So LiteRT for web, this link. And here we have the npm install command. So let me copy it. Let me remove this and then paste it like so. And then furthermore, I'm going to also install the tfjs or the Tensorflow library. So here I go Tensorflow/tfjs. I'm installing this library so that I can convert my images into tensors. And this was the only way I could do so. So let's install it. And now let's wait for a bit. Alright, so now with my dependencies installed and my server running, let's now talk about the model that we're going to be using. So last year, I released a video where I fine-tuned or I trained a YOLO model on a certain data set. So basically, my model identifies coins in an image, and I'll link the video in the description if you also want to train your model via YOLO. And then furthermore, after training, YOLO produces a .pt file. I then used another notebook where I took that .pt file and then converted it into tflite. The tflite format is accepted by the LiteRT.js library. Anyways, I've already exported the model and I've already saved it on my PC. So this is my YOLO tflite file, and I'm gonna put it in the public folder. So now that I have moved it, let's close it and let's try using my tflite model. So I'm gonna go to app.tsx and let's do a use effect. So use effect, And I want to run this use effect on mount. So it's going to be an empty array. Let's import it. And then let's use the documentation here. So let me scroll down and we have to import LiteRT. So let me just copy this. I paste it here. Let's create a function for it. So here I go const init LiteRT. So it's an async function. And then here I go await. And then let's go back to the documentation. And let's go back, paste it here. So now we need to import our local instance of LiteRT. So according to the documentation, it's within the node modules folder. So here I go node modules / at LiteRT.js / core / wasm and then another slash. Now with that done, let's load our model. So here I go local model. Let's assign it a variable const equals await load and compile. So I load my model. So let's import it first from the LiteRT/JS core library and then the model. So I go /yolo.tflite, which is the file name of my model. Anyways, then we go comma and then it accepts an argument or a couple of arguments. So we have something called accelerator and I want to use the WebAssembly accelerator and it looks fine for now. So now at the end, let's actually use this function. So here I go init LiteRT. So this seems fine for now. I'm going to ignore this TypeScript error. We're going to use this model later on, but let's go back. And yeah, we don't have any errors. Let's go to the console and let's see if everything's fine. So at the end, it says created Tensorflow Lite delegate for CPU. It means that our model works. This means that our model has been successfully loaded into memory. That's nice to see. Let's head back. And I want to assign this local model to a state. So here I go const model set model equals use state. I'm doing this so I can use this model throughout my project. So anyways, so use state of type compiled model. And if the model hasn't loaded, it can be null as well. So the default value is null. So let's import compiled model from the same LiteRT.js library. And then let's scroll down around here. Let's go set model local model. So now we have assigned our model instance to our local model variable. And then at the end, let's create a return block to prevent memory leaks. So here I go if local model. So if the model has been loaded, I can go local model.delete. So we have an error. I think, yeah, local model is not defined. So let's scroll up and here, let's go let local model equals null. And then let's remove the const here. So it's being reassigned here. Let's see what the error is. Okay, so it's a TypeScript error. So it's of type compiled model or null. All right, so this seems fine for now. Let me give myself some space here and here. So this looks a little bit cleaner. Let me close this panel as well. And now this time, let's create an image picker component. So let's scroll down and then let's remove all of this. Let me scroll down more and more and more. We have a lot of boilerplate. Let's remove all of this. This is not needed. Actually, before creating an image picker, I want to display some information about my model. So here I can go h1 model details like so. And then if my model has loaded, so it's question mark. So if my model is now in memory or if it's not, no, I can create another div like so. And here we can go h2 input details. Let's end this tag and then let's go paragraph and then let's get the input details. So to do so, I go json.stringify model.get input details and get input details. And this function returns an array. So I'm going to get the first item and most probably it's the only item. But anyways, dot shape. So get the input shape, comma, null, comma 2. So I don't want a function to transform my results and my indentation for this JSON value. Now let's end this paragraph and then we can do the same for output details as well. So h2 output details and this code seems fine. So we basically have another function called get output details that, as the name suggests, gives us the output shape of our model. Okay, so now autocomplete helped us. Let's now test our code out. But before that, we have some few errors. Okay, so it's mostly import errors. Let me remove this and let me remove this as well. So this seems fine for now. Let's go back. Let me close this. Let's refresh. And here, as you can see, we have our input and output details coming up. This means that our code worked. However, we just have the number 2, which makes no sense. So let's go back to VS Code and see what's wrong. Okay, so I know what's the error. We have to remove a bracket here and a bracket here. And let's do the same here as well. Bracket here and a bracket here is removed. Let's go back. And now here, as you can see, let me refresh. And now here, as you can see, we have our input and output details. And if you don't know about YOLO, basically the input shape is, so the first item is our batch size. So in this case, it's 1. And the next 2 elements are our height and width. So 640 by 640. And then the last or the third element is the color channels. So red, green, and blue, or RGB. And then next we have the output details. So the first item within this array or this dictionary is the batch size. So just like before. And then we have 300, which is the number of detections per image. And then the last number, which is 6, is the number of attributes per image. But later on in this video, I'm going to explain you both of these input and output shapes in detail. But anyways, now that our model has been loaded, let me now create an image picker. So I'm going to create a form. Let's first create an input. So input type equals file, and it should accept images. Okay, so now we have an input, this input. Okay, and then within this input, we have an onChange event, and this will be responsible to change the image source. So it accepts a parameter E, which is the event detail. And for now, let's keep it empty. And let's now define our onChange handler. So let me scroll up. Let's create a function here. So let's call it const handle file change equals event of type react.change event. And it's an input element. Yes, that seems fine for now. Let's end this function. And within the body of this function, you can go const file equals event.target.files. So if it does exist, we get the first item. And if the file does exist, we can go const object URL equals URL.create object URL of file. And then when that's done, I can just do a console.log of the object URL. And now let's scroll down. And let me give myself some space here, and let's scroll down and let's put our handle file change function here. So handle file change with E passed. So let me now explain you my function that I just built. So basically this function checks if the user has uploaded a file, and from that file we ask React to create a URL out of it, and then later on we just console.log that URL. Let's go back to the browser. Let me open the window, the console window. Let's put it to the side here, and this one to the side as well. Let me refresh. So the model has been loaded. Let's browse, and I already have an image. And here, as you can see, we now have our URL coming up. So now let's take this URL and then display it to the front end. So let's scroll up. I want to create another state for our URL. So here I go, image URL. Actually, image src is better. So set image src, use state of type string, or it can be null as well. That's it. And let's scroll down around here, and then we just set the object URL to image src. So here I go, set image src. Now that I have set my image source, let's now render it. So here I go, if the image src exists, so conditional rendering. So image src, and then we have a style. So within the style, I do width of 300 pixels, comma, a height of auto. And yeah, this seems fine for now. So we have an error here. So we have to close the image tag. Now let's go back to the browser. Let's refresh and let's see if our code works. So I upload my image, and now here, as you can see, my image is now being uploaded. That's great to see. Let's go back. And finally, let's now try doing inference on our image. So to do so, I'm going to have to assign this a ref so that React can access the image information. So let's scroll up, let's create a ref like so. So here I go, const image ref equals use ref. So it's of type HTML image element. Let's import use ref, and then let's scroll down. Let's assign it our ref. So ref equals image ref. And then let's create a button that performs inference for us. So here I go, button on click, and then I call this function perform inference. And then between these button tags, I'm gonna have my title. So here I go, run inference. So now I have to define my perform inference function. So let's scroll up. Here I go, const perform inference, and it's gonna be an async function like so. So here I go, if image ref dot current, or it's better to just go if not image ref dot current, I just return. So I just exit out of this function if there is no image existing. Let's now convert our image into a tensor. So I go let tf tensor of type tf.tensor3d equals tf.browser.from pixels. So here I pass in my image, so image ref dot current. So now it looks like I need to fix my imports. So let's scroll up, import star as tf from Tensorflow /tfjs, and then let me give myself some space here. Scroll down here, and then my next step here is gonna have to resize this image to my input shape. So in this case, I would have to resize my image to 640 by 640, which is basically the height and width that our model expects. So here I go, tf.image.resize by linear, and then I pass in my tf tensor, which is the tensor I have to transform, and then the height and width, which is 640 by 640. And then at the end, I will have to normalize this tensor. So I divide all of these tensors by 255. Now when that's done, let's do a console.log of tf tensor. So now let's head to the browser and test our code. So let's browse, select an image, let's click on run inference. And here, as you can see, we now have our tensor coming up. So let me expand this, and notice that we have a shape of 640 by 640, which is the height and width that our image expects. And we also have a color channel coming up. So in this case, it's 3, which is exactly what our model needs. This means that our model is almost ready to process our images. So let's go back, and there's one step that we need to do. So let's create a variable const transform tensor equals tf tensor dot expand dims. So I expand my dimensions, and I expand my first dimension. Sorry, not my first dimension, but my axis. So I believe this is the x-axis. And then when that's done, I will have to transform this tensor image into a float32 array. So here I go, dot data sync. So now when that's done, let's cast it to float32. So const input array equals new float32 array, and I pass in my transformed tensor, and then I convert this array into a tensor that LiteRT.js can read. So here I go, const input tensor equals new tensor, and I pass in my array and then the expected shape. So here I go 1, 640, whoops, not 540, it's 640, 40, and then my color channel. So now I import tensor from my LiteRT.js library, and then let's log out our input tensor. So let me copy this, paste it here. So now let's test out our code. Let's go to the browser, let me refresh. Let's browse for an image, take an image, run inference. And now here, as you can see, we now have a tensor object. So now we have successfully transformed our image into a tensor object. Let's just pass this tensor to our model. So here I go, const results equals model. It's actually a weight. So if the model exists, we do dot run, and then we pass in our input tensor. And then at the end, we just do a console.log of our results. So here I just got results. Let's refresh. Let's take an image again, run inference. And now here, as you can see, we now have an array. However, notice that we don't have a proper output, or we don't have a detections coming up. We just have a bunch of variables. So to get the proper results, let me just remove this. Here we can go if results. So if the results exist, we can go const output equals await results. So results is an array. So I get the first item from results dot data. And then we can just do a console.log of output. That's it. So let me refresh and let's test out our code once again. So let's browse for an image, select our image, run inference. And here, as you can see, we now have a float array coming up. And this float array contains all of our detections. Some of you might be confused on what this array means and what our output shape means. So let me explain it to you now. So now let's take the time to learn a bit more about our model. So first I go to netron.app, which basically is a web app that gives me information about my model. So I click on open model, then I click on YOLO.tflite, which is the model I'm going to be using. And then let's click on the first one. Let me zoom in like so. And then let's click on images. And here, let me zoom in. As you can see, our input or our model is going to accept an input of this shape. And furthermore, our model is going to give an output of this shape. Some of you might be confused on these tensor shapes. So now let me explain it to you now. So now let's dive deeper into the shapes. So the first number here, 1, is our batch size. So our model can only accept one image at a time. And then 640 and 640 are our height and width. Furthermore, we have the number 3, which is our color channels. So RGB, red, green, and blue. And then let's go further on our output shape. So 1, again, the batch size. 300 is the amount of detections our model can do. And 6 is the number of attributes per detection. So this is how our model's output is gonna look like. It's gonna be an array of around 300 detections, where every 6 items within the array are gonna be the attributes of our detection. So for example, our first 4 attributes are gonna be the coordinates of our detection, and then we're gonna have a confidence score, and then we're gonna have a class label. So basically, whether the model has detected a 1-cent coin, a 2-cent coin, or etc. And then this is going to be repeated around 300 times. So all in all, we're going to have an array with 6 attributes per detection, and we're going to have 300 detections at a time. In total, we're going to have 1800 items within our detection array. So now that we know about the details of our output and input shapes, let's head back to VS Code. Alright, so now that we know about our model, its input shape and output shape, and why this model outputs around 1800 elements, let's now write some code to parse our output. So let's go back and let's create an array for detections. So const detections, let me remove this console.log. And let's create a for loop. So for let I equals 0, I less than the number of detections. So let's create a variable called max detections I plus plus. So let's loop through this array. Let me create a variable for this. Let's scroll up, const max detections. So we have 300 maximum detections. Now let's scroll down. So within my for loop here, I can create an offset variable, const offset equals I multiplied by the attributes per detection. And as we all know, the attributes per detection is going to be 6. Let's scroll up, const attributes per detection is 6. Scroll down once again. So here I go const x1, so I get the x1 coordinate. So output offset plus 0. And then let's do the same for y1. So it's offset plus 1. X2 is offset plus 2. Y2 is offset plus 3. Then we have the confidence score, which is the 4th element. And then we have the class ID, which is the 5th element. That's great. And then we can perform an additional check. So if the confidence of my detection is more than 0.5, which is our threshold, so then we can push this detection into our detections array. So here I go detections dot push. Actually, it's better for me to create a separate variable for our height and width of our detection or our box that we're going to be rendering on top of our image or on top of each detection. So the height is going to be y2 minus y1 const width. So the width of our box that we're going to be rendering is the difference between x2 and x1, and then we push in our detection like so. So class ID, and then we have a confidence, and then x1, y1, width, and height. And now I want to create a state variable for our detections. So let's scroll up, and let's create a state variable like so. So const detections, set detections. So use state, and we need to create a type for our detection. So let me scroll up, and then let's create a detection. So type detection. So it's x1 of type number, y1 of type number. Then we have a height of type number, a width of type number, and a confidence and class ID. So now let's pass in our detection like so. And now that we've defined our detections state, let's scroll down. And just after this for loop, so around here, I go set detections, and I pass in my detections. And I would like to log out how my detections look like. So I create a use effect like so. And I want this use effect to run every time my detections array has changed. Detections. Then let's just do console.log of detections. So now let's test out our code. Let's go back to the browser, refresh, pick an image, run inference. And here, as you can see, we have an array of 3 elements, which perfectly matches our image. We have 3 coins, and we have a class ID. And according to my dataset, we also have classes. So each class corresponds to a certain label. So for example, we have a class ID of 2. And in this case, a class ID of 2 corresponds to a label of 5 cents. So that's great to see. This means that our code works. Let's now render our detections to the browser. So let's go back to VS Code. So let me scroll down around here. So just after this block, so around here. So I want to check if the detections exist. So if the detections array is more than 0, and if it is more than 0, I create a heading detections like so. Let's create a div actually. So div here, and then let's add this div like so. Let's create an unordered list. So detections.map. The first item is going to be the detection itself, and then the index. I'm going to use my index as the key. So a list item, key, index. Let's end this list item like so. And then within each list item, I display label. So it's detection dot. Now we have the class ID, and let's display the confidence. So I go confidence, detection dot confidence, and I round it to 2 decimal points. So 2 fixed, 2 like so. So let's now test this out. Let me refresh, browse for an image, run inference. And here, as you can see, we now have our detections. So our labels and their confidence is coming up. However, these labels are in integers, and we want our labels to come as proper labels. So I want 1 cent, 2 cent, and 5 cent coming up instead of these numbers. So let's create an array for that. So let me scroll all the way up. Let's create a variable for that. So const, it's better to create it here. So const class names. So the first one was 1 cent. If I recall correctly, the first one is 1 cent. The second one is 2 cents. Third one is 5 cents, and so on and so forth. So 2 cents, 5 cents, 10 cents, and so on and so forth. Let's give myself some space here, and let's scroll down all the way here. And here I go class names. So it's an array like so. Let's go back. And here, as you can see, our proper label names are coming up. That's great to see. So let's now move on to the last part of this project. Let's use our coordinates, or our x and y, and the height and width properties of each detection to display rectangles around each coin or around each detection. To do so, I'm going to have to create a canvas element, and my canvas element is going to require a ref. I'm doing this so I can manipulate my canvas via JavaScript. So let's create a ref. So here I go const canvas ref of type HTML canvas element. Let's scroll down once again around here, and let's create a canvas like so. So it has a ref canvas ref, and I end this tag, and I want this canvas to come over my image. So let's create a div like so, and I want to wrap this div around my image and my canvas. So end my div here. Let's scroll up. So I assign it a style. So I want the position to be relative, comma, display to be inline block, and we're gonna have to change the image as well. So here I go display block, and I'm gonna change the canvas element as well. So style, and then I end my curly brackets like so. So here I go position absolute, comma. So I want this to be on the top left of my parent element. So top 0, left 0, and pointer events to none. That's it. So let's now actually render our detections over my canvas. So let's scroll up to my use effect. So basically every time my detections change, I want to re-render my canvas. So first I check if detections exists. So if detections.length is equals 0, so I return, and then I get my canvas and my image instances. So const canvas equals canvas ref.current, const image equals image ref.current, like so. And then if my canvas and my image do not exist, I simply exit out of this function like so. And then I get my context of my canvas. So const ctx equals canvas.getContext. And if my context does not exist, I return. And then for my next step here, I'm gonna change my canvas height and width to the image. So canvas.width equals image.width. It's actually client width. I believe that's more accurate. And I'm gonna do the same to the height. And then here I go ctx.clearRect. So I display a clear rectangle over my whole image. Canvas.width, canvas.height, ctx.line_width 2. So a stroke of 2 or a stroke width of 2. And then here I go detections.for each. So for each detection within my image, I get the x1, y1 width and height from each detection. ctx.stroke style, so I set it to red. So I want my stroke to be red or my rectangle to be red. And then finally, over each detection, I display a rectangle. So here I go ctx.stroke rect x1, y1, width, height. So basically, I'm just displaying a simple rectangle over each detection. That's it. So now let's end this for each loop, curly bracket and then a bracket. That's it. So let's now test our code out. Let me refresh, browse for an image, take an image, run inference, and here as you can see our rectangles are not coming up. Actually they are coming up, but they're really small. So what's the problem here? Well, let's do a console.log of our detections. So let me scroll up, console.log, detections. Let's go back, refresh, browse for an image, run inference. And here within our array, notice that our x, y, height, and width numbers are very small. Basically, what's happening here is that YOLO gives us our coordinates in relative terms. They do not give us absolute coordinates. So now let's convert our coordinates to absolute coordinates. Let me remove this. To do so, here I go x1 multiplied by image.width, y1 multiplied by image.height, and let's do the same here, image.width, image.height. That's it. Let's now go back, refresh the page, test out our code once again, run inference, and here as you can see, our rectangles are coming up in their correct positions. That's great to see. The core of our project has successfully been done. However, there's a problem within our project. Notice that our app.tsx file has gotten very large. It's nearly 200 lines. So I'm going to take the time to actually make my code more modular and cleaner and easier to read. Again, this is optional. You don't have to do it, but I'm going to do it for readability. So my first step here would be to modularize my image picker. So within SRC, I'm going to create a new file. Let's call it image picker.tsx, and here I go const image picker equals, it's actually of type react.fc equals, so it's a function or a component, and then at the end I'm going to go export default image picker. And let's go back, let me cut out this code, let's paste it here. We need a return block, return like so, and then we need to redefine our handle file change function. So let me scroll up around here, let's take our handle file change function, let's save it to reformat, put in our code here, and we have a few errors. So we have set image src, so I'm going to make it a prop, or my function, I'm going to make this function as a prop to this component. So let's define our interface, image picker props. So let's do on image selected image src of type string, and let's put it here, so of type image picker props like so, and then within my bracket here on image selected, so this is going to be a prop, and let's replace our set image src function to on image selected call. So this is going to be a callback, and this is going to run every time the user changes an image or selects an image. So I replace set image src to on image selected. Let me give myself some space here. Let's go back and let's use this component. So let me scroll down around here and let's go image picker on image selected equals, so we're getting the source from the callback, so set image src to the src. That's it. Let's now fix our imports like so, and this should be fine. Let's go back to our code, refresh, browse, and hopefully our image picker works. Yes, it works just fine. Let's take another image. Yep, it worked just as expected. Let's go back and simplify more of our code here. So I'm going to take my image and my canvas, and I'm going to convert them into another component. So new file, let's call it detection results.tsx, and then here I go const detection results equals, it's actually of type react.fc equals a component, and then at the end here I go export default detection results, and then let's go back and I'm gonna take all of this code here, so starting from this div and ending with this div, let's cut it, go back, return, and paste it like so. And here we have a few errors, so our image src and our refs are undefined, so they're going to be the props. So let's create a type for this. So interface detection results props. Actually, let me make it smaller. It was a bit too distracting. Okay, anyways, so image src is going to be a string, or it's going to be null as well. Then we have detections of type detection, and let's bring in our detection type. So I remove this. Let's go here, detections like so, and let's use our detection like so. Then we have our refs, so image ref, so it's react.ref object, and the same goes for canvas ref. So now let's use our interface, so it's detection results props, and within my arguments here we are passing in our props like so. So it looks like detections is not being used. That's because I'm not rendering my detections. So let's scroll down around here, let's cut this code out. Let's create another div around this, or an empty element. Scroll down, put it here, and let's paste in our detection rendering code. That's it. So class names is not defined. So let's scroll up, get the class names from here, and I paste it around here like so. Let me give myself some space here. And yeah, this should work just fine. So now let's render our detection results. So here I go detection results, and I pass in my detections like so, and my image src and my refs like so. So we have ref object errors, so let's fix it. So let's go back to detection results, and it can be either image element or it can be null. Let's do the same to canvas ref. And now we don't have any errors. Actually, we do have an error around here. So let's import detection as well. Actually, I would have to export my detection type. So let's scroll down. So here I go export type detection. So let's go back to use it. So here I go type detection. Okay, so now let's see if our code works. Let me refresh. Model is still working. Let's browse for an image. Image picker is still working. Run inference. And yeah, so as you can see, my code still works. However, there's one more step we can do. We can convert our model into a hook. So let's do so now. So within src, I'm going to create a new folder. Let's call it hooks. And here I'm going to create a file called useModel.ts. So const useModel equals, so useModel is a function. And let's copy all of our code that's related to our model. So I copy, or I cut this code, paste it here, and all of this code as well. So basically, wherever we are loading the model, we remove it like so, and let's paste it. And it's more or less, the logic is the same. Every time the useModel function is mounted, we load our model. Basically, everything is the same as just before. So now let's fix our code. So let me import compiled model. Let's import useState. Let's import useEffect. Let's import load LiteRT. Let's import this function. And at the end, let's return our model instance. So at the end, I scroll down, I go return model. After this function ends, I do export default use model. That's it. Let's now use our hook. So I'll scroll up. Here I go import use model from use model. And then let's use this hook. So here I go const model equals use model. Actually, let's drag it down here. That seems better. And we have import errors. So let's just remove these. That's it. So now let's test out our code once again. Let's refresh. So our model is still loading. That's great to see. Let's browse for an image, take an image, run inference. And as you can see, our project still works. And basically we've refactored our code from 200 lines to around 113 lines. We've also made our project easier to read and cleaner as well. That's it for today. In this video, you guys learned about the LiteRT library, and you guys also learned about running the YOLO model within React. If you guys have any questions, any opinions, or any suggestions, let me know within the comment section below. Till then, see you later and bye bye.